Hello guys. Today we will be starting a new series on discrete mathematics. This particular subject is being covered in many universities for different branches of engineering. We will be mainly pertaining to the discrete mathematics, which covers all the branches of engineering, including computer science, information technology, and so on. And above that, the syllabus that we will be referring to closely will be the Pune University syllabus. So we will be mainly concentrating on discrete structures or discrete mathematical structures, and the syllabus that we will be closely following will be our SPPU or Pune University's syllabus, because this particular syllabus is very complete in its own nature, and the points that are being covered, like recursion, graph theory, and different paths in it, they are all very complete. So this will be the syllabus that we will be closely following to, and also some extra points which are not covered in the syllabus but are very important for the point of view in understanding the subject also will be covered. Okay, so let's just dive right into it. It is going to be a long series with different kinds of lectures that we will be seeing into. I will try to cover as many problems as we can in the subject, because it is a mathematical subject, so there are many problems to be covered in it. Okay, so let's dive right into it. The first question that we need to answer over here is that what exactly is discrete mathematics? Because we have already been studying mathematics since a very long time, but discrete mathematics holds its own very prime importance in engineering and also in case of computer and information technology, because we're going to use all the components inside discrete theory for programming, for constructing a more robust module, which will help us indirectly to construct a more robust program. So that is why discrete structures holds a very unique importance in the field of computer science. Discrete mathematics is a very old subject, and it is being taught to computer science and information technology, and even electronic students since a very long time. Even its components are included in our basic 11th and 12th standard as well. So this is the reason why this subject is very important, because it is very primitive and it has not been changed, and it will never change. This subject has been a part of engineering since ages, and it is going to be a part of engineering for the coming ages as well, because it forms a very important background, a very robust and a very important background to how you can solve more complex problems by the help of these discrete structures. So this subject is very important for us as engineers, as mathematicians. This subject is very important. Now we need to clearly understand what is the exact difference in discrete mathematics and other branches of mathematics. To be very specific, there are exactly two branches of mathematics. So those go like this. There are exactly two branches of mathematics where you can divide them into continuous mathematics continuous mathematics, and the second branch of mathematics being discrete mathematics. Now we need to understand what exactly is the difference between both of them, and why is discrete mathematics called as discrete mathematics, because these things are very important to understand in the beginning of the subject, so that some doubts are cleared right away. And above this, we are conducting this particular tutorial series video in order to not just score good marks, but to have a very depth knowledge about this particular branch of mathematics. Fine. So now the difference between continuous mathematics and discrete mathematics goes something like this, which is, in case of continuous mathematics, the different intervals between the numbers can be divided into an infinite numbers, which means that let's say you have got two numbers in continuous mathematics. Those two numbers could be any two numbers, let's say 3 and 4. Okay, now in this case of normal continuous mathematics, numbers of 3 and 4, I can have a number which is in between this interval of 3 and 4. So let's say that number is now 3.5. okay, so now what I have exactly done is that in the numbers of 3 to 4, I have divided this interval, which was 1, the interval was 1. Now I have divided this interval to 0.5, which is greater than 3, which would be 3.5, and again 0.5 smaller than 4, which is 3.5. So now in this particular way, how I have divided the interval between 3 and 4 is what makes continuous mathematics so special. Now in this case, if you see, I can further divide this interval of 3 and 5. I can further divide this interval of 3 and 3.5 to a more smaller interval like 3.25 as well, and then I can further divide this interval of 3 and 3.25 to a smaller number like 3.15, and so on. This is the special characteristics that we have of continuous mathematics, where you can keep on dividing the different intervals of numbers that already exist. Now on its opposite case, let's see what is going to happen with discrete mathematics. Now in case of discrete mathematics, what happens is, when you have got two intervals of numbers in discrete mathematics, so let's say those intervals are binary 2 and 3, okay, the same numbers of binary 2 and 3. So how are you going to represent a binary 2? You can very easily have 0 1 0, and you can have the binary 3 as 0 1 1. Now in this case, if you see, the two numbers in discrete mathematics are binary 2 and binary 3, and the main difference that exists over here in case of continuous and discrete mathematics is that you cannot divide this interval. This interval is going to stay fixed. You can no further divide this interval into decimals like how we have done over here. That is the main difference between discrete mathematics and continuous mathematics over here, which is you cannot further divide a binary number 2 and 3. Now this particular difference gives rise to many different kinds of problems. So these problems are, since you can divide a number, since you can divide an interval in continuous mathematics, we have got different branches of continuous mathematics as differentiation, where we particularly differentiate an interval, we particularly differentiate a number, we differentiate a formula in order to split it into different terms. And we also have got branches like integration. In case of this integration and in case of this differentiation, you can definitely divide an interval, and you can also integrate an interval of numbers, interval of formulas, in order to have better clarity about the changes that are happening. This can be done only in continuous mathematics, because you can divide an interval over here. But now in case of discrete mathematics, there is no differentiation and there is no integration, because you cannot divide an interval over here. So once we know why does differentiation and integration does not exist in discrete mathematics, what kind of studies are there in discrete mathematics? All those kinds of studies are present where you are not supposed to divide the interval, you are supposed to consider the interval as it is. What are such kinds of studies that we have over here? We have got studies like set theory, then we have got studies like graph, We have got studies like trees and so on. So this differentiation between continuous mathematics and discrete mathematics is very important. Even you must be able to answer the questions like why does not differentiation and integration exist in set theory, in graph, in trees and stuff like this, and even in propositional logic. So this is the answer to this question, and knowing the answer to this question also is very important and very interesting. And this is why, since you can divide a number, you can divide an interval in continuous mathematics, you have got differentiation integration over here. And since you cannot divide an interval into further parts, you've got graph theory, you've got trees, you've got sets, where you have to treat every structure as a whole, and such things exist only in discrete mathematics. Okay, now before we end the first video, before we end the introduction to discrete structures, I would like to cover one more small point, which is what exactly is an proposition. We are going to deal with proposition, we are going to deal with propositional clauses and so many complicated things in the further videos. But for now, we must clearly understand what is an proposition. Okay, proposition can also be called as a statement. You've seen, you've even read, or even staff in your college probably have not explained you what exactly is an proposition. But knowing what exactly is a proposition is very useful and very important. Okay, so now in case of knowing what exactly is a proposition, we can understand proposition by this simple definition of a proposition, which says that a proposition is a statement, a proposition is a declarative sentence which has got a truth value. Okay, even if you don't understand much words from this, I will try to explain the definition to you. A proposition is a declarative, a proposition is a declarative sentence which has a truth value. A proposition is a declarative sentence with a truth value. Now, whenever we are studying definitions, I always say that try to understand every word that is present in a definition. It is a definition, not an explanation. So, you will not have useless words inside and definition. A definition itself is supposed to be very precise and very accurate to the word. So, you must understand every word that is present in the definition to understand the concept better. Now, in this case, a proposition is a declarative sentence with a truth value. In case of this definition, you must understand the word declarative over here, which means that you must always have a statement like this water is wet, or it is going to rain today, full stop. Stuff like this. You cannot have imperative, you cannot have assertive, you cannot have commanding sentences like will you please get me a glass of water. In case of declarative sentences, okay, now see, pay attention. The examples that we would see is what is exactly an declarative sentence. The first one being this towel is wet. Okay, this is a declarative sentence, a sentence which conveys meaning. And second one, another example I would like to give is for a declarative sentence. You can have water is clean and healthy. Done. This also is an declarative sentence. Now let's see some examples of which are not a declarative sentence. So the first example for that would be something like will it rain today? Will it rain today? This is not a declarative sentence because it does not convey any meaning, but it has got a question. so it is not a declarative sentence. Further, you can have many examples where you have got question marks inside it, can you please get me a glass of water, please. Sorry, please has already come. Okay, so can you please get a glass of water? Even this people will debate on this particular sentence whether it is a declarative sentence or not. People will debate on this whether it is a declarative sentence or not. But according to my studies, I find that this is not a declarative sentence because it has got a hidden command in it. The reason that I say this is not a declarative sentence is because if we consider this to be a declarative sentence, then it conveys, it takes, it causes many problems in our further studies. So I suggest that these sentences are not declarative sentences because they have got a question mark inside them, so they are not a declarative sentence. Fine. Now once we understand what is a declarative sentence, we need to now proceed with our definition, which is a proposition is a declarative sentence with a truth value. Now, in order to proceed with the understanding of our definition, let's have some more examples like this. A proposition with a truth value. In this case, let's have one example, which is there are 9 planets in our solar system. There are 9 planets in our solar system. If you see in this particular sentence, it is a declarative sentence because there is no question mark, and apart from that, you can also see that it has got a truth value. So this truth value for this sentence being true. Now it is not important, and it is very important, it is not important to see whether the truth value of this sentence is true or false. Okay, understanding this is very, very important. The definition says that it must have only a truth value. The definition does not say whether it has to be true or false. It can be anything. It can be either a true value or it can be a false value. Understanding this is very important. A proposition does not declare that the sentence is going to be true. It can be either true or it can be false. For example, this is a proposition, and I will give you another example. Like we have 20 hours in a day. Even this is a proposition. Even this is a proposition because it is a declarative sentence and it has got a truth value which is false. Okay. Then let's take one more example. Let's say the sentence would be something like 3 plus 3 is equal to 6. Is this an proposition? Yes, it is definitely an proposition because it is a declarative sentence with a truth value, like 3 plus 3 is equal to 6, and the truth value of this is true. Okay, let's see one more example. Let's say the fourth example over here would be something like 5 into 2 is equal to 20. Is this an proposition? Yes, it is again an proposition, but its truth value is false, but it is definitely a proposition. Okay, these are all examples of valid propositions. These are all declarative sentences with some truth value, true or false. Now let's proceed ahead with to see some examples where it is not a proposition. Such examples would be when is your birthday? when is your birthday? Now if you see at this sentence, it is definitely not a proposition, because it voids the first rule itself, which is it is not a declarative sentence, and you cannot say that its truth value is either true or false, because it depends on the answer and its validity. It's a whole other thing. But now in this case, since it is a question, it does not have a truth value of true or false, so it is not a proposition. Then second one would be something like x minus 4 is equal to 0. Even if you see at this particular sentence, it is a very important example. Even this is not a proposition. Why is it not a proposition? Because you cannot say whether it is true or false. Its value of true or false depends largely on this particular variable of x. So now in this case, if this x is equal to 4, only then this becomes valid. Or if I say this x is not is equal to 4, also then it becomes valid, because then in this case the truth value would be true, in this case the truth value would be false. So in this case, only when I have some value for this variable x, okay, only when I have some value for this variable x, you can decide that whether the entire truth value is true or false, and based on that you can say that it is a proposition. So as of now, since you don't know the value of this x at this particular point, you cannot say, okay, at this particular point you cannot say whether it is a proposition, because you cannot decide its truth value. Okay, then let's have some more examples. Something like what a wonderful day. This also is a very unique example. Even in this case, it is clearly not a proposition, because it is not a proposition because you cannot decide its truth value. Okay, that is why it is not a proposition. So now you clearly understand what is a proposition and what is not a proposition. You can ask for any doubts in the comment section. You can also write your own examples for statements which are proposition, statements which are not propositions. I would be really very happy to read about them. And now I believe that concludes our first lecture on discrete structures. In this particular lecture we have learnt what exactly is discrete structures, and also what exactly is a proposition, how to differentiate sentences between which of them is a proposition, which of them is not a proposition. Okay, so yeah, I believe that concludes our first lecture on this. Now, as a request from many students from different colleges who have been asking me for some help on this subject, I would like to tell them that we have also started some personalized tuitions for this subject, because I have received many requests from students saying that they are very poor in this, they are not able to understand stuff, more advanced stuff in the subject. So yes, we are going to start some personalized tuitions for the subject as well, and for the same you can contact me, which is Ritesh. So yes, this is just for the students who have requested me to start some kind of a class for this subject. So yes, we will be also starting some special tuitions for the subject, where we will cover everything, every aspect of the subject in detail, and also it will help you to understand the subject in a lot of depth, and also give you a very good opportunity to do more wonderful things in the subject. So that's it for today. In the coming lectures we will be focusing on concepts like what are different kinds of logical operations, logical operatives, then constructing sentences from logical operations, and so on. DNFs, normal forms. Yes, normal forms, very important point. Normal forms we will be covering. So yeah, see you in the next lecture. Thank you.